Hello, everyone. It's a great pleasure to meet you all today. I'm truly honored to be here and would like to express my sincere appreciation to AEGIS-O Plus for providing this wonderful opportunity. My name is Jessica O from Accuver headquarters, a global leader in mobile network test solutions. In this presentation, I will share our E2E task experience utilizing Accuver solutions. Today's agenda includes the following topics: testbed setup, ORAN TIFC E2E task result details, and then I will conclude with our strengths. In this test, an E2E task environment was configured by integrating 3G ORU and Nokia ODU CU into AGU Plus existing 5G NSA network environment. The objective of the task was to evaluate the E2E performance in an environment where both LTE and 5G O-RAN equipment were co-deployed. To evaluate the system performance for commercial deployment, key E2E test items were selectively tested. Accuver participated as the test equipment provider in this PlugFest. Accuver's auto regression test solution, AEGIS-O, integrates various Accuver products to support O-RAN tasks. In collaboration with the TM AEGIS Manager, ESCAPE AMS orchestrates Accuver's equipment to execute most of the test cases defined in TIFC E2E, Working Group 4, and Working Group 5. It also generates automatic test reports. In this PlugFest, AEGIS Manager, AEGIS Mobile, and ESCAPE AMS were utilized.
For the test, rows were collected from AEGIS Mobile and the result analyzed in AEGIS Manager were used to generate ORAN E2E test reports in ESCAPE AMS. ESCAPE AMS provides test scheduling and test automation feature for ORAN-defined test cases. ORAN operators can reduce time, costs, and human resources leveraging these features. ESCAPE plays a critical role by managing the device's auto calls, collecting and storing logs, and sending them for ESCAPE Manager to analyze.
The test was conducted based on the following as specifications defined by ORAN TIFC. This test validates E2E ORAN C-plane functionality with a single UE for both LTE and 5G NSA. The test verifies the successful attach and detach procedures through power on and power off of the UE. The task is performed in excellent to radio conditions for 10 iterations, measuring and capturing attach success rate, detach success rate, and attach latency. This test validates E2E O-RAN C-plane functionality with multiple UEs. The test applies to either LTE or 5G NSA and aims to verify the successful attach and detach procedure through the power on and power off of multiple UEs. The test is performed in excellent to radio conditions for 10 iterations, measuring and capturing attach success rate, detach success rate, and attach latency. This test verifies intra-OCU and intra-ODU handover for all UE, validating the OCU, ODU, and ORU functionality in handling intercept mobility when two ORUs are connected to one ODU. The test measures the downlink uplink throughput variations, handover latency, interruption, and packet loss during mobility. Test scenarios are classified into SA and NSA with a core plus following 3GPP standards. The purpose of the test is to measure the peak user data throughput and the downlink directions where data is transmitted from the application server to the UE. A stationary UE is placed under excellent radio condition in an isolated cell.
The peak user data throughput and the uplink direction was also measured. A stationary UE is placed under excellent radio condition inside an isolated cell.
The purpose of this test is to measure the user experience, data throughput, and the downlink direction while varying received radio signal quality. The UV is placed in different stationary points inside the isolated cell. The user experience data throughput and uplink were also measured. The purpose of this test is to measure the user experience data throughput in both downlink and uplink in parallel, while varying received radio signal quality. The UV is placed in different stationary points inside the isolated cell. The test also includes the measurement of peak data throughput of UV located in the excellent radio conditions, and cell edge coverage data throughput of UV located at the cell edge in the poor radio conditions. Accuver's XCAR art for ORAN solutions not only support TIFG TUI testing, but also enables automated ORAN working group 4, working group 5 IoT testing configurations. To set up working group 4 and 5 testing, the spectrum analyzer XCAT IXA must be integrated to provide a cloud reference. XCAT AI must automatically execute working group 4 and 5 test scenarios and generate test reports in the same format as OTIC batching report. This helps save various resources required for IoT testing within our equipment. With AEGIS-O, we can monitor and analyze real-time packets from frontal, middle, and backhaul interface. Accuver has a diverse product portfolio for O-RAN E2E and IoT testing. Partner companies can configure the XCAP art for O-RAN system based on their desired test cases collection. Once the XCAP art is set up, XCAP AM must automatically execute the collected test cases and generates reports. Accuver will continue enhancing test equipment to enable broader testing of O-RAN test scenarios in the future. That's all I prepared for the presentation. Once again, Accuver sincerely thanks AEGIS-O Plus and our test partners for the outstanding collaboration in this PlugFest. Thank you for having me.